So what we've done here is just combined what we've had a look at earlier in a series in parallel combination. Now, it's very important that you keep track of exactly what you're doing, and we're measuring from this end, so we're going to come in from this end here. But the first thing you see is you've got a parallel combination here in right capacitance. But this branch here, C5 and C6, is the first one that you need to calculate, because that combination there is actually a parallel combination. And if you work that out, that should be 12.5 microfarad, which, if you look at that, you've got 25 microfarad, 25 microfarad. Right, there's two of them in series here, which is a parallel combination for capacitance, and you should be half that value, which is 12.5. Now the next step is that we work on this area, right? So we've worked out C5, C6, which I've written here, and then you got C7 in parallel, in the circuit. So that becomes a series calculation. So you can see here we've got the results of 12.5, which I've written in as C5, C6 in parallel with each other as far as the combination goes, and then we add in the C7 and you end up with 1012.5 microfarad all up. So we progress on, and now we've worked all this area out here. So we've got C5, C6 and C7 right calculated, which is here. Now that's in a circuit, I'm in series with C4, but in calculation it's a parallel combination as far as deriving your right result. So now we have C4 times 2, which is here, which is that right value there, as you'll see, divided by C4 plus this result here. And you can see there we've got 20 microfarad times 1012.5 microfarad divided by 20 microfarad plus 1012.5 microfarad, and we get a result there of 19.61 microfarad. So everything's done up to this point, so that's all done. Now we've got this parallel combination of capacitors in circuit, which now becomes a series calculation to find out the right total capacitance, and we've done that over here. So C2 plus C3, you end up with 101 microfarad, which is 100 plus the 1 microfarad here. And now we've worked out that little bit. Now we're going to tie that into all this and C1, because they're all now in series with each other as far as the circuit goes. But in calculation, you can see that it's a parallel calculation. So we end up with 1 over 3, which is this value here, 1 over 4, which is this value here, and then we've got 1 over C1, which is the final capacitor in the circuit here. We put those values down, we work that calculation out, you end up with these values along here, and then we sum those together, we end up with this value here, and then we find the inverse of that, we end up with 6.22 microfarad.